Science is often thought of as simply a collection of facts which has been handed down to us from some great authority in the past. But of course the reality is much more complicated than that. The facts that we know today about science were only arrived at after a great deal of research, debate. In fact, some of the greatest scientists in history have been spectacularly wrong in the past. So what all of this means is that one thing that is never very far away from science is controversy. I work in climate science, and one of my research topics is atmospheric turbulence. The fact that the climate can change was once very controversial amongst the scientific community, and of course it still is controversial today, not in the science community anymore, but amongst the general public. So I'm interested in tracking the history of controversy in science. So I'm travelling north to meet Geoffrey Bolton, who's a Fellow of the Royal Society, and he is noted for the work he's done that shows that climate has changed very dramatically quite recently in geological terms. So where exactly are we heading, Geoffrey?
Well, we've just come out of the lowlands, and shortly we'll be turning off to the west, to the area around Ben Nevis, in particular to Glen Roy, where there are quite extraordinary features on the hillsides, which are quite unique in Britain and illustrate a quite extraordinary controversy of about 200 years ago, which is the beginnings of a modern view of the way in which climate works and how it evolves through time.
Well, I can't wait to see them.
Let's hope my safe driving will conduct you there.
Wow. So these are the parallel roads of Glen Roy.
Yeah, they are. They're amazing, aren't they? These horizontal lines on the hillside. There are three of them, and they all maintain pretty much the same altitude through this valley, Glen Roy and Glen Gloy to the west. And they puzzle people for many years. Charles Darwin came here in 1838, fresh from his voyage with the Beagle to South America, where he was sure he'd seen similar features along hillsides which had shell sands on them, and which he, I think, correctly interpreted as having been beaches that had lain at sea level. And he came here and was convinced that he was seeing the same thing, and indeed he published a paper in the Royal Society's Philosophical Transactions saying exactly that in 1839.
So the big question is, was he right?
Well, I'm afraid he wasn't. That seems a hard thing to say about Charles Darwin.
Yes.
No, he got it wrong. There were two problems, however. One of them was that he didn't see any seashells here, which is what he'd expected. And the other is something you can see if we look at this map. And this shows the distribution of these parallel roads. And what you see is that the roads marked by these red lines occur in Glen Roy and they occur in Glen Gloy, but nowhere else. And Darwin couldn't explain why they weren't more widespread, for if the whole of Western Scotland had been uplifted by tectonic forces, that's what he would have expected. The solution came 3 or 4 years later when young Swiss geologist Louis Agassiz came here. He saw these features and thought immediately he knew how they'd formed in a way that explained why they occurred in these valleys, but not in adjacent valleys, nor even in any other part of the Northwest Highlands. He'd seen close by here bedrock surfaces which had typical grooves ground on them by glaciers. And what he did is what I've done, is to draw this blue line on the map showing where the terminus of a glacier lay that dammed up these lakes in the valleys. The water draining over the cols at their heads and the elevation of the cols determining how high the individual roads were.
So if we were standing here, 12,000 years ago, we'd be standing at the bottom of a lake, right?
We would. We'd have been blowing bubbles and we'd have been beneath about 150 metres of water.
So shall we find somewhere to warm up?
I think so.
Well, I think what we saw today was a splendid example of how progress is made in science, with the introduction of new ideas, new evidence, dramatically changing our scientific understanding of the facts, obliterating an old theory and allowing a new theory to come in and take its place.
And it's important to recognise as well that Darwin, who later became a great scientific icon, could make serious errors, as he did in Glen Roy. This is the Philosophical Transactions from 1839, with Darwin's paper in it. If you look at Darwin's map, then the location and elevation of the roads is pretty much exactly the same as you would find in a modern map using satellite imagery. So Darwin's facts have remained steady and constant and usable But of course his theories now we were completely wrong. And Darwin himself, of course, recognized this. And I've got a copy here of his book on the descent of man. And he writes, false facts are highly injurious to the progress of science, for they often endure long. But false views do little harm, for everyone takes a great pleasure in proving their falseness.
That's a great quotation. And of course, scientific publishing played a critical role in the resolution of this particular controversy. Before the launch of Philosophical Transactions in 1665, scientific ideas were not accessible to the public. They were not published. They were confined to the private letters of the scientists. So the advent of scientific publishing was a means to formalise scientific controversy.
It stimulated tremendous debate, but not only from the scientific community itself, but actually from the broader public. Edmund Halley, in the early years of the 18th century, estimated the age of the Earth to be far, far greater than the age deduced from the biblical record. Of course, in the public domain, he was strongly criticised for having the boldness to publish this openly in the Philosophical Transactions. But it's crucial, really, for the progress of science and human understanding that we are prepared to produce bold new ideas based on evidence rather than merely accepting some external authority.
And that brings us nicely to the present day and contemporary climate change. Scientists have overwhelming evidence that the climate has changed over the past century or so, and that the cause of that change is not natural variability, which is associated with the origin of the parallel roads, but human influence. And we have what has been referred to as a consensus gap between what we have in the scientific community, which is overwhelming levels of agreement, and what exists in some parts of the public sphere, which is a perception that that level of agreement is absent.
And notwithstanding controversies like that, I mean, the crucial thing is that science has to be an open public enterprise, rather than one contained behind closed laboratory doors. And the challenge of the future is we've got to keep it that way.
Well, I'll certainly drink to that. Cheers.